Welcome to the Unit 1 Section 4 video on literal equations. Let's talk about identity and equality properties. We've already talked a little bit about identity properties. In algebra, there are certain statements or properties that are true for any number. We saw that when we were verifying solutions. Consider what value makes each statement below true. What makes b plus 15 equal 15? What value for b makes that true? Well, your answer should be 0 because 0 plus 15 is 15. How about 4780 plus c equals 4780? Same thing. We can put in 0 for c, and that would give us a true statement. So the solution to each equation here is 0. Since the sum of any number and 0 is equal to the number, 0 is called the additive identity. So the additive identity property states for any number a plus 0 equals 0 plus a, which is equal to a. Now consider the value that makes each of the following statements true here. 5x equals 5. What times 5 gives you 5? Well, your answer should be 1. What times 655 gives you 655? Again, your answer should be 1. Since the product of any number and 1 is equal to the number, 1 is called the multiplicative identity. So for any number a times 1 equals 1 times a, which is equal to a. 0 is a factor in each of these statements. 0 times 11 is equal to 0. 2 times 5 times 0 is equal to 0. And 4 times 0 times 27 times 8 is also equal to 0. In all of these cases, 0 is multiplied somewhere in there. And if you have 0 being multiplied anywhere in a statement, then you can say that the solution is going to be 0. So for any number a times 0 equals 0 times a, which is equal to 0. You have already used the addition, subtraction, multiplication, and division properties of equality. Properties of equality are statements that preserve the balance on each side of the equation. The following are additional properties of equality. So you have the reflexive property, a equals a. Anything is equal to itself. The symmetric property states that if a equals b, then b equals a. It doesn't matter which side is which when you have an equation. You can flip the sides of the equation and it's still an equal equation. It's still true. Transitive property states that if a equals b and b equals c, then a equals c. Okay? Because if b is equal to both of them, then they have to be equal to each other. And then finally, the substitution property states that if a equals b, then a may be replaced by b. So let's look at how these properties are used in simplifying this expression here. So we start by doing our order of operations. So we're going to start in the parentheses, and we're going to start with the division in the parentheses. 48 divided by 4 gives us 12. And here we use substitution because 48 divided by 4 is equal to 12. And since 48 divided by 4 is equal to 12, we substituted in 12 for 48 divided by 4. Next thing we're going to do is finish off the parentheses by doing 12 minus 12. That gives us 0. Again, we have used substitution. Because 12 minus 12 is equal to 0, we can substitute 0 in place of 12 minus 12. Next thing to do in our order of operations, we are going to multiply 6 times 0. Multiplying 6 times 0 gives us 0. That is the multiplicative property of 0, because anything times 0 gives you 0. Our next step in our order of operations is to do the 9 times 1. That is going to be multiplicative identity, because anything times 1 gives you that number. And then finally, 0 plus 9 is additive identity, because 0 plus any number gives you that number. Let's talk about a couple of other properties that are useful, starting with the commutative and associative properties. To find the sum or product of numbers easily, you can use commutative and associative properties. The commutative property states that the order in which you add or multiply numbers does not change their sum or product. So here, a plus b is the same as b plus a. Same with multiplication. A times b is the same as b times a. So think about it with numbers. 2 plus 3 equals 5. 3 plus 2 is also equal to 5. So 2 plus 3, 3 plus 2, it doesn't matter which order you add, you're still going to end up with 5. Same thing with multiplication. 2 times 3 is 6, 3 times 2 is 6. 2 times 3 is the same as 3 times 2. The associative property states that the way you group numbers when adding or multiplying does not change their sum or product. Again, it all comes down to the order in which you do add or multiply does not matter if they're all together. So let's take a look at an example of this. We're going to simplify this expression and we'll indicate all the properties used. So we'll start off by flipping what's in the parentheses. Instead of doing 5 plus 6x, we'll do 6x plus 5. That's our commutative property of addition. Then we're going to shift our parentheses using the associative property of addition. And then we can use distributive property to pull our x out. And that gives us 3 plus 6 in our parentheses. And then we can substitute 3 plus 6 with 9. And that's as far as we can take it. 9x is a term and 5 is a term, but they are not like terms, so they can't be combined. So this is as far as we can simplify it. The next example, we're simplifying 5n plus 2 times the quantity n squared plus 4n, close the quantity, plus n squared. So we're going to start off by distributing the 2 to the n squared plus 4n. Next, we are going to flip what's in the parentheses using the commutative property of addition. Then we are going to group things differently because everything is being added. We can group things in a different way. That puts our 5n plus 8n together and our 2n squared plus n squared together. So this is essentially combining our like terms or grouping our like terms using the associative property. And then finally, we're going to use distributive property and substitution property to finish out our simplification. It's useful to know how to manipulate equations and move things around when you're working with formulas. A formula is an equation that states a rule for the relationship between certain quantities. A common formula for distance is d equals rt, where r is the average speed and d is time. In this formula, the distance d is isolated. You can rearrange a formula to isolate any variable by using inverse operations. This is called solving for a variable. To solve for a variable, you're going to locate the variable you are asked to solve for in the equation, identify the operations on this variable and the order in which they are applied, and then use inverse operations to undo operations and isolate the variable. So in this example, we're going to use a formula and we're going to solve for the variable that we need. So in 2004, Ernst van Dijk won the wheelchair race of the Boston Marathon with a time of about 1.3 hours. The race was about 26.2 miles. What is his average speed? Use the formula d equals rt and round your answer to the nearest tenth. So we're going to start off with our formula, and we need to find out what his average speed is. Okay, so we need to find out what his rate is. Okay, because speed is a rate. So d equals rt. We've got to get the t off of that r. So since we're multiplying the r and the t, we're going to divide each side by t, and that gives us d over t equals r. Now that we have a formula for our rate, we can use the formula to solve for r. By doing r equals d over t, we can put in what our distance was, which is 26.2 miles, and we can put in our time, which is 1.3 hours, and we end up with 20.2. And our units here would be in miles per hour. So Van Dyke's average speed was about 20.2 miles per hour. Being able to rearrange for a variable also can be useful if you need an equation for a conversion factor. So here, the formula for a Fahrenheit temperature in terms of degrees Celsius is F equals 9/5 C plus 32. If you have a Celsius temperature, you can find what the temperature is in Fahrenheit using this formula. But what if you're given a Fahrenheit temperature and you need to find what the Celsius temperature is? We can solve this equation for C. So we're going to start with our equation, and we're going to first subtract 32 from each side. Then we're going to multiply each side by 5/9, the reciprocal of 9/5, to get C by itself. And that gives us 5/9 times the quantity, F minus 32. That is our formula for taking a Fahrenheit temperature and converting it to Celsius. So now we're going to talk about solving literal equations. A formula is a type of literal equation. A literal equation is an equation with two or more variables. To solve for one of the variables, we use the inverse operations. So for this example, we want to solve m minus n equals 5 for m, which means we want to get m by itself on one side. To do this, we got to get the minus n off of the left-hand side. And we're going to do that by adding n to each side. And that gives us m equals 5 plus n. And so now we have solved our equation for m. In this example, we're going to solve m over k equals x for k. Well, k is in the denominator, so how are we going to handle that? We're going to start by multiplying each side by k to get k in the numerator. And that leaves us with m equals kx. But we want k by itself. So now we're going to divide each side by x. And that leaves us with m over x equals k. So now we have solved the equation for k. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.